Hello, 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 hello. Okay, so people from Zoom, they can hear me, right? Yeah. Okay. So my computer is, oh wait. Hello. Okay. So, oh, this one needs to be. So, my computer is having an issue where it sometimes disconnects the internet. So I have multiple recordings enabled so that I don't lose the class. Okay. So, today is the final class, and like you might think this course is hard because of me, but it's not the case. I'm just giving you the questions, but still, I know that even with knowing the questions, and this is the process of the solution, practicing it 4 to 5 times, still, uh, this course is hard. That's why the average is low. And I actually have a higher average because, in past years, I believe they don't give out the questions, and that's why the average is even lower. So uh, I think uh, the topics that have been covered, I like you would be confident that the like I had made the questions to be as complicated as possible. So I myself can think if I can make it more complicated, but that's the good thing that you know like okay, so we know how to do complicated stuff, so we'll be good doing anything in life, right? Like if we so here's a problem which is in the slide, right? And then I made another problem, making it as difficult as possible I can think. So like if we go over the easy problem and the complicated problem, then I believe that we will have a good depth of knowledge about everything. And it's not that it's hard. It's basically very easy because I also provide you the cheat sheet. I don't know if you make your own cheat sheet, you would remember to have these things. Like you wouldn't know what to put in your cheat sheet, right? Yes. No, just I provide the cheat sheet and it will have everything you need. Yes. So, but although these questions might look difficult, the answer is just here in this summary. So, and you can also go back to the lecture videos. And if you don't understand anything, you can go back to the lecture videos and understand it in depth. But today, what I'm going to do is just quickly solve the problems. That's my goal. So yesterday, I showed you some problems on caching. I will go back to them. But first, let me cover these problems. And I think the problems I gave you, there will be no problems outside the problems I have taught and I gave you here, because like I'm basically covered everything. So I will still make like a, a written document on how you should prepare for the final. So a written document of these, you should go over these documents or these videos, and you'll be good for the final. So I remember when I took this course, I didn't know where to start, like what to do. So I ended up practicing 10 different universities final exams, because you can get them, but you don't have to do that for this course, because I'll be exactly providing you that you should go over these problems. You should go over quiz one practice problem, quiz two practice problem, midterm practice problem, and the new problem. So I'll have it in a good way. And it will be, if you do want to look at final questions from other universities, you are free to do so. But first, finish the problems that I tell you to, because I'll be making the questions. Uh, so yeah, just I'll give you a written document of, if you cover these things, you are good. Another thing I will give out is another MCQ quiz, open book. It's open book. It's open book, and from MCQ quiz 3, you will have a lot of questions in the final. So I could have given it in the final just for fun, but just so make sure you do quiz 3. I haven't given it out yet, but it's going to be an open book MCQ, and so make sure you do that. I'll also mention that in the document, that make sure you do quiz 3 MCQ, because even if you get 0 in it, doesn't matter, because just it's open book, you can't get 0. But basically, if you don't do quiz 3 MCQ, you'll have a lot of MCQs in the final that you can do if you have gone through the lectures very, very well. But yeah. So let's start today's class. I'm going to teach you. It's very simple. You might already know it, but still some of you might not know it. So if you are working with a single monitor, you can get some of the benefits of a dual monitor if you use I know you have it in Mac, but on Windows, it's Windows button plus tab. And if you press Windows button and tab, you can open a new desktop. So today it's going to be helpful, because I'll be quickly going over from the question to the solution. So, so here I pressed Windows button and tab and opened a new desktop. And now I want two things. So the questions and the solutions. So I'm opening the questions here. So these are the questions without the solutions. And I'll open the solutions in another page. So in another desktop. So I just put it in. And now if I press Control and Windows button, I can quickly switch from one desktop to another. So basically, without look, it's like you have two monitors if you switch between desktop. Most of you, I think, already know it, but it's very helpful. Okay, so we did cover this before, right? The single cycle, oh no, this is the multi-cycle pipelining. And it first told us to indicate where the data hazards might occur. So we initially see that the answer is in T3, right? But this next line is using T3. So there will be a data hazard here. The answer is in T5, but we are not using T5, right? So no data hazard on the second line. On the this third load, we are storing this value to T0. So, and we are using it in the next line. So there will be a data hazard here. So so far we have identified 2 data hazards. This T3 is being saved here, but is being used here again. This T5 is being saved here, but is being used here again. So we identified 4 data hazards. Now, I'm doing it quickly because I want to cover more topics. But if you want to know what's data hazards, how we resolve them, you can go back to the lecture video and just slowly watch what you need to watch. But as we have identified the data hazards, right? Now, what we have to do, so we have gone through this first question, right? And now draw a diagram to show how to use forwarding to resolve data hazards. In your question, we won't, because I am giving you practice problems for forwarding, right? So assume every question in the final will ask you to think that you have the forwarding algorithm enabled in your hardware. So you don't have to look for stalls. What if you didn't have forwarding? How many stalls would you need, right? So I'm not going to ask questions on that, but you should know that if you went through the lecture well. So we will assume we have the forwarding option. Okay, so now we know that there are 5 cycles, right? We first have to fetch the code, decode the code, execute the code. If there's a memory, if you have to access the memory, M and W, which is writing back to the memory or the register. We have these 5 actions for all of the instructions. So, but when you start drawing things, right, you will get confused. So it's better to just write the answer quickly here so that you don't waste time thinking. So let us quickly write the actual answers here, right, on the side so that we don't waste our time. How do we answer this question in the exam? If you have been in my lecture, you would know that I covered how this happens and also gave a summary. So this is the summary that you need in the exam. So I'm just going over the solutions, but if you want to understand how this happens, go back to my lecture video, okay? So these questions are easy. You have to just use this summary table, which will be included in the cheat sheet. I will provide the cheat sheet. No personal cheat sheet allowed. Okay. So if there's an addition or subtraction followed by another addition, subtraction, load, or store, there will be 0 stalls because you can forward the result. Okay. So if this is the case, this is the first instruction, this is the second instruction, your result, you don't need a stall. If it's you're loading something, right? But R1 is not being used in the base address, then you need 0 stall. Okay, let me just change color. But if R1, if you have a load command, and if R1 is being used in the base address, then you must need 1 stall. And similarly, if you are using R1 as a operand, which is RS or RT, you must need 1 stall. Okay. So if this is the first instruction and this is the second, or this is the second instruction, you need 1 stall. That's it. You have everything you need to know just in this summary and solve the question. Okay. So let us quickly solve the question. I'm moving back to the question. Okay. So what did we learn? If there's a load, and if load is the first instruction followed by a add, like an R type instruction, and you are using the value that has been loaded, then you must have 1 stall. The first instruction cannot have any stall, right? It's just the first instruction. Okay, now this is T5. This is T5. I'm not using it. And we also know that after add, you don't need any stall. You can use forwarding. So in no way, because we know the summary, there's no possible way after an add we need a stall. So 0 stall here. And then after load, if we use that as an operand, we need a stall, 1 stall. We are using T3. We are using T3 here, right? But we know after an add, we can just forward values. So 0 stall. And we know after an add, we don't need any stall. You need a stall only after the load. Okay. That's what we know from the summary. So 0 stalls here. And if you write up to this part, you're going to get 70 to 80% of the marks. Like, you got this question right. Now the drawing part is just for fun, but we need to understand it. The drawing part is there so that you know how we forward the values. And again, I'm quickly going over it. I haven't covered how we are stalling, why we are stalling. I already covered that in the lectures. I'm just giving you how to practice for the final. Fetch, decode, execute, memory, and write back, right? So you can see here we have the fetch, decode, execute, memory, write back, right? Now we have to do something like this. So you can plan ahead because you already know the answer, right? You already know what's the answer. You can plan ahead and just say, okay, we don't need any stall for the first instruction. And then we need 1 stall. So the second instruction, it's just going to be nothing. And the third instruction, we execute this add. Fourth instruction is 0 stalls. So we just do the load. Fifth instruction, 1 stall. So it's going to be a no op, which is do nothing. Sixth instruction, we do the add. Seventh instruction, we do this add. eighth instruction, we do the subtract. So we already have the frame of what we are going to draw. So because we already written the answers here, we know what to do. And now it's just try to do it small, because you are going this way, right? It's going to get big. So make these icons really small so that you have space. F, D, E, M, W. And I'm quickly doing it because we need a stall here. Make sure this is under this. Just try to maintain the balance, okay? Now we know that F, D. If we let's say in your exam you don't have time, right? This is time consuming. So you can just write F, E, M, F, D, E, W, F, D. Oh, this is going to be all cross, 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 and then F, D, E, M, W, F, D, E, M, W, F, D, E, M, W. Done, right? Now you have some marks for showing how the forwarding occurs, okay? So let's just quickly look at it. I'm also going to give you the theory behind it, just short. You know, we are loading a value, right? But after execution, we know which value we are going to load, right? So this is where we know what is the value. So we can forward it to here. If you want more description, go back to the lecture. But this is the like short description, because after execution, we know what value we are going to store in the memory. And that's why we don't need to store it in the memory. We can pass it to the ALU directly, so that there's no like, or else we needed another stall. Okay, yes, question. Oh, yeah. Good catch. So in the solution, you would see that it's in the memory here. So uh, this is nice. So you know the pitfalls you can make. So this is one. So the point of production is after the memory. And this is how you would forward it. Okay. So if we do that, if we had done that, we would have lost half a mark. Okay. So we know this is the part of the memory we need to use. So we are forwarding it to the ALU. Now, for the next one, we have four hazards. This is one hazard, two hazard, three hazard, and four. The fourth hazard is here. Okay. So the second hazard. So load T0, we have to pass it to this add. So this load has to pass it to this add. Second one done. Third one, this T3, we have to pass it to the next add. So this add executes and passes it to the next add, and sub. This T5 is passed to the next subtraction operation, so it's passed. So done. Question complete. I did this because I realized I don't have much time in the examination. And if you do this, you'll get full marks. You don't have to uh, put the letters in blocks if you don't have time. You just need to you'll get marked on these sticks, and also these stalls, and also if you can correctly identify the data hazards. Okay, any question on this? Yes. Yes. And it's also in the a better, if you have, don't like, if you can get something with less effort, then do it roughly. You will not get more marks for beautification. Just do it as minimally you can. I just need the answers. Okay. Yes. Forwarding. Okay, you have to go back to the lecture then, but it's basically uh, you know, if I say it in two sentences, you know, this at T5, right? When is it going to happen? After the write back, right? But your processor knows, like, this is a add operation, right? Let's say we add something and store it to X, but sub is using the X. If we follow the normal convention, we have the results here. And if we want to do that, we have to put in like two stalls just to get that. But this adding happens where? In this stage, right? So as you know the answer, you can forward it. So that's the concept of forwarding in briefly, if I explain. Okay. So this is similar, but I tried to make this as hard as possible. And but it's easy. You can't make this hard. If you have this solution sheet, if you have this summary sheet, you know all the possible combinations, right? So there's nothing that hard. So first one, stall 0, because it's the first one. There's no reason you would stall. Let's identify what are the hazards. So T3, right? We are using T3 here. Now T4 here. We are using it here. T4 here. So this is the first hazard. This is the second hazard. This is the third hazard. No, because we are storing the value. This is not a hazard. We are storing T4 into the memory, right? So this is not a hazard. This is not a hazard. Okay, next one. We're adding it here, and this is a hazard. Yes, so this is the third hazard. Load. If we load it, and yes, this is a hazard, fourth hazard. Okay. So we have 4 hazards here. In the solution, you would see that it really looks like a hazard, but it's not. So I will update this solution. So we have actually 4 hazards. Okay. Yes. It's not about the usage, but what happens. T4 The value of T4 gets stored into the memory, but the value of T4 doesn't change. So that's why it doesn't matter. We are not changing the value, so it doesn't become a hazard. Store. So this will be up. I have this correct version. I always update the solution. So just after this class, I'll update. Okay, so for hazards and stalls, we are using T3 here, right? Again, this can be a trick question. If we had load T3 and $4 S0, right? And if we load T3 and for S1, is this going to be a hazard? Is this a hazard? Hazard? Is this a hazard? Anyone wants to? Yes. Yes, we are not changing the, no, we are changing the value of T3 here, right? But we're not using T3 here. We're again changing the value. So there's no hazard here. And this is a trick question. So there will be 0 stalls if this was the case, but it's not. We are using T3, so there is going to be a stall here. This is not a trick question, but this is. So this is no. So stall 0. You wouldn't even mark it, when you mark it, you wouldn't even mark it. You wouldn't even put circles over it. So if you do, you lose marks if I give you this question. Okay. Now, anyone can tell me this is a hazard and how many stalls we need? We go back to the summary. Load after store, right? There are two options. Whether we use it inside the if it's the base address, there has to be a stall. If it's not the base address, there's 0 stalls. Let's check. Do we use it as a base address? No. So stall is going to be 0. Just follow the cheat sheet. And I'll provide you the final cheat sheet within 2 days. Yeah. So that you can practice at home. Okay. After store, there's no stall, okay? Because you're storing it. You're not changing a value. You're changing a value inside memory. So that doesn't matter. After add, there's no stall. But here, this time, I'm using the loaded value as a base address, right? So there is going to be a stall. So I provided, I tried to provide every case possible. That's why I called it hard, because you see a store where you need a stall and you see a store where you don't need a stall. And then the same thing you're going to, if you do till this part, you will get 80% of the grade. So if you don't have time, just do up until this, okay? You get 80% of the grade. If you do have time, then you show how the forwarding works with this. So here is the solution. Again, for load, you have to take it from memory, but check that Memory to memory. All right. Oh, so see, I didn't even see, but I did it correct this time. But it's so complicated. For this load and store, you go memory to memory. But for this load and store, because you are calculating the base and the offset, you give it to the ALU. And for this load, you tell like this is the memory location you want to access. Okay. Any questions on? Yes. No, it's a forwarding. A stall means XXXXX. Oh, yeah. Instruction 2 is a stall because of the load, previous load. Yes. Like this had a stall. It's this stall. This is 0. You forwarded it so that you didn't need to stop. Above it. Very hard, but it's very interesting. If you know what's happening, you can easily get, even if you don't know what's happening, if you look at the summary and if you use the cheat sheet, you can get 80% of the mark guaranteed here. Yes. Yes, because you get it. It's because we get our result in memory, right? Memory, it's we if we got the result in execution, then we didn't need any stall. Because we got the result in memory, that's why we needed a stall and a forwarding. If we didn't forward, then we needed more stalls. But yes. Scroll up. Yeah.
Scroll forward down. Okay, fantastic. So when we use the load word, the actual moment that the register gets that value is when we write, correct? On the W?
Not the actual moment, the next moment.
The next.
So we write in we know where to write in M. We select where to write with or what to write in M. We access the memory. Then in the next step, we write it. But with forwarding, we don't wait for the next step. We know this is the value. We just pass it. Yes.
Down below, but T4, if you look at the add there, we have an execution happening.
We did forwarding. This one, add and load. The load above it. This one. Can you, if I number it out, 1, 2, 3, 4, 5, 6. Number 2, right? Okay, number 2. T4 is being written to, yes.
For the add, for access the execution, that register, but it has a register.
In T4?
Yes.
This load. Wait. load here and just add is T4. So before it's being decoded, it's being executed, right? Yes, we have to forward it here as well. Yes, a good catch. So another thing is just this forwarding, because there's no stalls, we weren't too much bothered about it, but still, if you recognize that, okay, this T4, it hasn't been, if this happened on the decode stage, then we don't need to do it, because we know the first half we write and the next half we read. So if this add was in the decode stage, then we didn't need forwarding. But your name? Jaden pointed out a good thing, that this is not the decode stage. So that's why this value also needs to be forwarded to the to this line as well. That's what you get if you want to make it like the most complicated you can. But these are good things to think about, right? How complicated can these be? But there will be a simple one and a complicated one. And you know that 80% of the marks is, if you just follow the cheat sheet, you'll get it. So not that complicated. Okay. The next question is what you did for the quiz and the midterm, right? But you will be given some options, and then you have to select the options to implement this code. Yeah, so this is fun. It's like a puzzle programming problem. And I had a talk with Scott Fraserly, and he said like he's thinking like for the future, he wants this, like he went to a conference and found that these problems are really good for the students. They help them think. And he didn't make one. He said, if I make one, I should send it to him. So I made this one, and I'll make one for the final two. But could be this, it won't be this one. But I'll see. But this is, if you have some instructions, how would you arrange them to get the solution? So the best thing about this is you don't have to go back to the TA multiple times that your solution is also correct, because when we do this, because these two lines, when I'm going to provide the TAs the solution key, I will say these two lines are interchangeable, right? And then also, I don't see any other lines interchangeable, but I'll make sure multiple optimal solutions will be accounted for. But your answer could be just this sequence. And there are wrong instructions inside as well. But any solution will be accepted And after the final, you'll also have to check your scripts, and even after that, if you feel that your solution is still right, I will check it and I will give you marks on that spot. Like I'll accept any correct solution. Yes, you had a question. You had a question? Yeah, I just quickly deleted it. That's why. Like I have been, yeah. So that won't be in the question if it's in here. Okay. So this is, yes. Oh yeah. Yes, I know this one. Okay, so I will update this just after the class and it will be all correct. Okay. So this is just an example, and I'll try to keep it simple because this becomes really hard. Or there will be a hard question just for like to just test out. But whatever I cover is going to be in the exam. So if you cover what I covered, you'll get 90%. And then that 10% is just there for me to make the exam like, or else if everybody can get 100%, it's not an exam, right? So 90% you'll get if you practice these, and 10% will be hard questions. So, uh, any any questions about this puzzle question? Okay, so this one, it's very simple. This question, it's basically asking you what's the CPI, and we covered in the performance lecture that if you have this this instruction happening 40% of the time and it takes 4 clock cycles, right? On average, then you just add them all up. 5 into 30 plus 4 into 10% plus 3 into 20% and divided by 100. Here is the CPI answer to the first question, right? We covered this, but I lost the recording. So I'll just re-record it for you. So it will be fine. But how much faster with machine B if we use a technology with load time that is two cycles? What it says is, what will happen if this wasn't 5, this was actually 2? Then you know what would happen. This will be replaced by 2, right? And you get a new CPI. And what you do afterwards is you have a old CPI, or the formula is written here. CPU time equals to number of instructions multiplied by CPI into cycle time. So CPU time old equals to this. This is the formula, right? You will be given this in the cheat sheet. And then you just compare the old against the new. And it didn't mention anything about the number of instruction being changed or the cycle time changing. Only the CPI changed. So you get 1.28. So CPU old takes 1.2 times more than CPU new. What does that mean? That means CPU new is 1.28 times faster than CPU old. Okay, because CPU old takes 1.28 times more than CPU new. So that's the answer, 1.28 times faster. And the final question, it says, how much faster would the machine be if we use 30% higher clock rate? So the formula was CPU time equal to number of instructions multiplied by CPI multiplied by cycle time. But in the question, it mentions 30% higher clock rate. So, and you will have the cheat sheet that I provide. And in there, you would see clock cycle equals to 1 by cycle time, right? So the formula would be number of instructions multiplied by CPI multiplied by 1 divided by clock cycle from this formula. Okay, we get this. Now, if we compare time old with time new, we get that these and these get crossed out from each other, and you have the clock cycle old and clock cycle new will be on the top because it gets like, yeah, division, right? And it mentioned in the formula, it's 30 the new clock cycle, the clock cycle new equals to 30% higher, which means it's 1.3 multiplied by clock cycle old, right? And if we just put this value here, 1.3 into clock cycle old, you cancel out this and this, you left with 1.3, and old equals 1.3 multiplied by time new. Time old equals to 1.3 times new. So the new one is 1.3 times faster than the old one, which I also did in this solution. Okay. It's very simple, and if you just practice it with the cheat sheet, you will be good with this. It's very easy to get marks. I can't make it complicated. This is simple. This question, you recognize this is the exact question from the assignment, and it's a good question to have on the final. So you will have this on the final. I'll change the values like just to surprise you, but the solution is in the media gallery. I also took the time to mention watch from 6.44 minutes to 19.49. Why I didn't provide the solution? Because the assignment is due on the Saturday. So if you practice this before Saturday, you can like answer it for the assignment. So, and the solution is easy. I basically did for every question, you have to do it 3 times. I did it once for P1, and you have to do it for P2 and P3. Don't worry about the length of the exam. I'll make sure that it's possible to easily complete it in 1 hour 40 minutes, so that you have like an hour of time. If you mess something up, or if you mess multiple things up, you can go back. Only if you practice well enough. If you don't practice well enough, then you would be confused with every question you would think, and then it will take a lot of time. But these, if you know what to do, you can actually finish the exam in 1 hour. Yeah. So the final question, this is fun, and also I will provide you this, and you have to highlight over it. Okay. How will the data path will be? Here is, I will also include this in the cheat sheet, but basically the second part of the question is, what are the values inside here? Okay. And you can directly put them from the cheat sheet. So it's an R type instruction, right? So one reg, let me make a copy of it here. Because we are doing sub, right? It's an R type instruction. What will be these values? Can I put it in one line? Wait. You go to the cheat sheet and you just put in the values. So it was in one. Oh, but I made it too big. So register destination, it's going to be 1. We use RD. LU source 0. Mem, this is for using the offset. So we don't use the offset. You don't, basically this is done, like if you look back your previous cohorts, this was done if you understand how the signals work, right? But if you were smart enough, you would bring this table in the cheat sheet, right? And then you just put in the values. This time I'm providing the cheat sheet, so I'm going to provide you this table and you can just put it in. Mem to register 0. You do register write. Yes, you do write back to RD, right? You don't read the memory, 0. You don't write to memory, 0. You don't do branching, 0. You have this specific code. This is trees designated. And then you don't jump, 0. And then if you do this for other instructions, let's say this one, it's a jump. And I'll provide you the solution for this, but basically we have to sign extend for this one. So everything 0 and jump. Yes. And I will put the what will be the command for jump. I will put it here, so you don't have to worry about it. Okay. The data flows. The data, only the path that the data flows. So no, just the data. So we are using this one, and then we have to use RD as well, right? Then, so this one has to be highlighted, and then we do this, and this is for the offset. We're not using the offset, so it's going to use 0, not this one. And then it's a sub operation, right? We don't use the memory. We take this other route and we go back and put it into RD, which is stated by this one. This is what you have to draw, okay? And the solution is also provided for you. Here, you also get this one. You don't have to do that. I just want the data path, okay? So you don't have to do, if you do, don't worry, it's still good, but you don't have to do the control paths. I just need the data path. And while you are doing this, you also have to PC plus 4 to get the next instruction. So don't forget about that. PC plus 4, and then we directly go take this route and just use a pencil or a pen to highlight over it so that the markers can mark you. For these ones, we went through them in the lecture. Yes, I'm going to get your question. But I'm again just bringing it up. So if you go to the pipelining lecture, you would see that this video, it has solutions to 4 problems and it goes over it in very detail, and in 40 minutes it covers like what you need for the exam, basically these 4 problems. So going over that would be a good idea, because this will carry a good weight of the final exam. So just go over this solution and you'll have what controls you need in the cheat sheet. Wait, I'll just check someone in Zoom. Okay. Your question. Oh yeah, I will update that to add and sub. Basically, nothing's going to change, but yeah, I just wanted to, for all R types, it's going to be the same thing. So, questions. Oh no. Yeah, you had a question. This one, this thing. Wait, this thing. Yes, and I think you should be thankful I'm giving you this, because it's easy marks. You just look at the cheat sheet and fill it in. And jump is not in the slides, but I will add the instruction for jump in the cheat sheet, so that, yeah. So I think if you have some marks, let's say 40% of the marks here, or 30, let's say 40%, right? It's free 40% marks just for putting it in. And in previous years, they brought their own cheat sheet. So ones who didn't have that in the cheat sheet, they were not, like, they had to think. No, you can still do it. You can just, it's not a giveaway in that sense. But if you do have it, then it's a giveaway. And yeah, I think so. Finally, if I just reiterate what you guys need to do. So what you need to do is, I'm going to post a third MCQ quiz exam, open book, right? The third exam will have a lot of MCQs in the final. So make sure you solve that. If you don't, no worries. I will take your percentage from the final, but it will be beneficial for you if you do the third MCQ open book exam. The next thing is, I'm going to provide you a document on these are the things, these are the problems you should practice. These are the videos you should watch from my lectures. And if you follow that document, I believe you will get, like, if you practice all of them, you'll get 90% of the grade. And if you are smart enough, you'll get 100% if you just follow that document. And you're free to look at other universities' exams. You'll find similar content, but I'll be specifically asking questions on what I covered. So you would be good if you follow those two things. Yeah, so that's it. Any questions? Yes. By tomorrow. By tomorrow. Yes. Quiz 3 is for practice, but it's an open book. So if you don't do it, I will add the percentage from the final, but which you don't want. It's an open book MCQ. Okay. And if you don't solve it, those same questions are going to be in the final. So just like, you should do it. Yes. Yes. In 2 days, I will provide you the cheat sheet. Any other question from Zoom? Okay. When highlighting the data path on the exam, wondering what's the best way to do that, assuming no. So if you have another, like a blue pen, if you bring a blue pen, that is good, right? And if you don't forget to bring the calculator, because you remember the questions on caching, they need the calculator, or it's very difficult. You can use the cheat sheet and put the values in. Okay, you don't need the calculator actually, but just bring it just to be safe. And I didn't go over the last 2 questions on cache. I'll make a video on it and post it. So yes, a bright color is okay.